Let's continue in section 4. We have looked at mean and median. Mode is really quick. I should have done that in the previous one. So let's do that first. Then we'll look at standard deviation and range. These are like totally out of order, but it doesn't really matter. We're going to cover those all at once right there. So let's take a look. Let's go up. And mode, I already had it written down. Mode's pretty easy. And you can either just analyze it yourself really quickly, or you can use a computer package, and there's a mode formula that you can type in. We'll be able to look all that stuff up. Okay, mode is just the most frequent data point or variable. So if you look above, it's pretty obvious. You have 8, 8, 10, 10, 10, 12. So obviously the mode is 10. So 10 is the mode of that data set. So it depends on the data set. In some cases, you want to know what the most frequent response is, not necessarily the average or the mean. So if you're doing responses like if you're categorizing, this is basically, I don't know, I'm figuring this out, but coming up with an example. If you are doing a categorical experiment and you're asking questions 1, 2, 3, 4, but those correspond to something like what's the most frequent color? Well, that might be what you report, right? So the people's most what do they like the most? It'll come up in mean and average and stuff, but you just report the mode, like what the response was, who responded the most from that selection. Okay, so I don't want to imply that it's not very good. It depends on the sequence, the idea. So that's mode, most frequent data point. Now let's go on to measures of dispersion, or how spread out the data set is. And this gets into variance and standard deviation, which is the next really important concept to describe these things, describe statistics. All right, so go ahead and write all this down. So first is measures of dispersion. Let's go ahead and highlight that. Or how spread out the data are. Or what we say, what is the deviation from the mean? Is it clumped towards the mean, or is it a bunch of stuff spread out? You can get the same mean with different data points. You have a bunch of these data points versus these data points. You could have exactly the same mean. So we want to be able to describe that concept. The first one is called the range. So the range R of a data set or variable. It's pretty simple. R is equal to the largest data value minus the smallest data value. So that's pretty simple. You just look at the largest value, smallest value, subtract them, and that's your range. It may or may not be useful, but that would be it. Let's go. So we can use, I have other ones, but since we did this one earlier, okay, I'll write another one. Okay, so for example, we have 4, 5, 7, 8, 8, 9, 10, 10, 12, 15, 18, 18. Then you can calculate R. R is the largest, which is 18, minus the smallest, which is 4. And the range is 14. So that gives you the total spread between points. May or may not be useful, but that's the range. Now let's do another cluster. So suppose we took the same one. To rewrite the same one, I can totally cheat now with my iPad. Just take the same range like this, or not range, sorry, same data set, except let's add one more data point, say 58. So if we add 58, now what does the range become in that data set? Well, the range now is 58 minus 4, which is 54. So look at the difference here. You have a range that's 54 versus a range that's 14 with only one data point difference. Well, that doesn't really tell us the whole story. That doesn't tell us a lot there. So this 54, we would consider that an outlier. And that's some of the vocabulary you need to pick up on with the reading. I'm trying to get through this kind of stuff. Well, this is the stuff, like we're here. Because we want to get into the calculations and doing the hypothesis testing and all that kind of stuff further. So just follow along, please. Okay, so this is affected by extreme values. What we call those outliers. Okay, so or outliers. So it may or may not be a good measure. We look at the range in different things, from biggest to smallest. I mean, that may be something you're really interested in. What's the largest and the smallest? Like, you may want to know that. So it's not a bad data point. It's just you got to know what it's telling you. But it doesn't give you a good idea, really, of all the data points, how spread out they are. If you look at those two, because they're pretty clustered between 4 and 18. So that's what you want to. Let's continue. I had to cut something out there. I forgot to do something. All right, here we go. So let's get right to it and what we're going to look at. So let's take that concept, but let's take that concept, but let's consider the mean. What's the average or mean of that data? So assume, so we're gonna do a little derivation here of this concept. So now let's let mu be the mean, and that's population mean of a data set. Then what we're going to do, so we're going to say x sub I represents each data point or data value. Sometimes we use that interchangeably, data point, data value, but it's actually the value. A point is implied to be an ordered pair, which is a point. And let's suppose we, instead of just looking at the last one and the first one subtracting, let's subtract each data point and look at what maybe that is, because we're looking at a deviation, the difference of the mean and the other values. So that would be, and consider the value x sub I minus mu. That's going to give us some data point. If we look at that and we add them all up, okay, so now add these up. Maybe that's something to look at. So now we're looking at the sum of all the differences. Might be something to consider. Okay, so we add them up. Remember the sum. So we sum x sub I minus mu, like that, and see what we get. Now, it turns out that, well, actually, let me show you an example. Hold on. Let me show you an example. So, for example, let's use 1, 2, 3, 4, 5. So there's our data set. What's the mean? Without even doing calculation, it has to be 3. So the mean mu is 3. So we know that has to be the mean. You can verify if you want, but that has to be it. It's the middle. It's also the median in this case because it's the dispersion on each side is the same. So that's the mean. There isn't a mode, by the way. So it's the mean and median. And then let's take each value and subtract it and see what we get. So if we do that sum, so the sum of x sub I minus mu is going to be the sum of x sub I minus 3 each time. And so we can actually do this calculation real simply. We're going to do 1 minus 3 plus, and I'm going to bring this down. Actually, what I can do is bring this, just pull that over. I think I can fit it here. 1 minus 3 plus 2 minus 3, right? I'm taking each data point, subtracting the mean, plus 3 minus 3, plus 4 minus 3, plus 5 minus 3. And you get -2 plus -1 plus 0 plus 1 plus 2. What does that add up to? That adds up to 0. Yes, you can see each of these values are going to annihilate each other. So can you see that that will happen every time? I mean, you have a little intuition about that. So that doesn't really tell us that doesn't tell us everything. Because you have positive and negative numbers, they're going to cancel each other out every time. So what we do or can look at is the absolute value of that. And then that could be your deviation. Okay, so you can prove that actually happens. So that's not a fluke. That has to happen, must happen every time. So if you take the sum, of x sub I minus mu, that will always be 0 if you adding all the data points. So what we end up doing, and I'm going to basically cut right to it, we want to consider that difference, but we want to divide by the number of data points. And so we first look at what's called a variance. So population variance. And that is sigma squared. So that's lowercase sigma squared. Use the I don't know, it didn't mean it. My hand made that disappear, sorry. Squared equal to, and then that ends up being the sum of that difference squared divided by the number of values. So this is called a population variance. You take the sum of x sub I minus mu. And you're squaring each case. So all of these right here would be squared. And when you square it, we know that makes it positive. And then you divide by n, where n is the number of data points. Okay, that's the population variance. But that's the wrong dimension. Like that's squared. What we then do is take the square root and make it into the same like size. And so this is called the standard deviation. This is the population standard deviation. So the population standard deviation is that. Okay, so that's sigma. It's equal to, and then you just take the square root of that. Hold on, let me fix this. I gotta fix my spelling errors here. Okay, sorry about that. Okay, so population standard deviation looks like this. And you do the square root of this. So you take this same thing, that whole deal there, and you square root that. Now, I will have you do at least one calculation by hand, probably two, the first quiz and the midterm. By the final, you're just going to do computer studies. We'll be way beyond this. So that's the standard deviation, and what that does is it's taking each of the differences, squaring them, and then dividing by n. So it, this idea is nice, but it doesn't really help us. It's kind of like going back to the range, but now but you want to look at each one. So you're looking at each difference of the mean. So the mean minus a data point, mean minus a data point. And then you square it. You add them all up, divide by the number of data points. Okay, and that should give you a feel for how much information is in that calculation. This is a statistic. A mean is a statistic of the data. This is a statistic of the data. And then from that, we can interpret a lot of information. And that's what we'll get to. Okay, a couple more things. So that, and I'll get to this in a bit here, but that's for population. The sample variance and standard deviation is slightly different, which I'll get to. We have a calculation formula. It looks like this. I'm going to move this over just to keep things a little more concise. This is equal to, and this is what I would call the calculation formula. And I'm not going to go through any of this. You can prove it. I can prove it for you if you really want me to show you. It looks like this. It's the square root of. You divide by n, but then in the middle, you can do this. You can take the sum of the squares of all the data points and then subtract the sum of x sub I quantity squared over n. I keep hitting an undo button down on my hand there. Make sure, okay, that's squared, and that's divided by n. I'm going to show you one and use this calculation. So you don't really need to use the calculation that's used for doing bigger calculations. We're not going to get into that. But I do want you to take, 5 or 6 and calculate a standard deviation, which we will be able to use this formula no problem. Okay, so this is the actual, so mu is the actual mean, and so that's the things I want to point out here. So mu is the actual mean of the population. So the standard deviation this is actual. Now keep in mind, in the long run, we won't have the population in most cases. And I say that loosely, but most cases we won't have it. We'll be doing sampling, and that's a slightly different. All right, so let's take a look at this example. What time is it? All right. I mean, how long have I done the video? Okay, so let's look at this example. We'll take exam scores, 65, or it doesn't matter what they are, 70, 71, 75. Before we were forced to go to Canvas for our grading, I would always calculate the mean, standard deviation, and I'd plot stuff. A lot of it was automatic, but now that we were forced by administration to go to Canvas, I don't do that. It takes a lot more time, and it's not worth it. So we just look at it. Okay, let's write a few things down. So suppose you have those data points. You can pretend whatever they are. I don't care. There are 1, 2, 3, 4, 5. So your n is 5. Always keep track of n. Let's calculate the the mean. And we're going to consider this population because it's the whole thing. So that's 65 plus 70 plus 71 plus 75 plus 95 divided by 5. And I already did that. Okay, so get out your calculator. You get 376 divided by 5. So the mean is 75.2. So that we got to deal with a 0.2. Oh well. All right, so the 0.2. All right, so you can already see that like most scores are below that. This is an ordered set, so I call this a set. I actually had it in order. And it's just a tick above that value. So this 95 is skewing the mean. And there's ways to tell that, but that's what I would see. That's why I don't really look at the mean that much. I look at more of the spread, high, low, and where things are clumped. It's just not enough with 30 students, 36, 40 students. You can kind of look at that data set and just analyze it. You don't need this sophisticated stuff. But you do for a big data sets, obviously. All right, so let's do this calculation. Sigma is equal to, and we'll use to the half power. So remember, you can do all this and then raise it to the half. And we'll do that on our calculators. So we take each data point, subtract from 75.2, and then we square it. And then we divide by 5, and then take the square root. All right, so I'm going to show you this whole thing. Okay, so I'm going to go big old long division bar. We're going to divide by 5, and then we'll raise the whole thing That's the square root of that whole thing. So that's a root. So it's 65 minus 75.2 squared plus, so this is what I want to see. I want to see you do this once or twice. 70 minus 75.2 squared plus 71 minus 75.2 squared plus 75 minus 75.2 squared plus 95 minus 75.2 squared all over 5. And you continue. Okay, so I'll show you what each one of those are over 5. And then we'll do the square root of all of that. So this is 10.2 squared plus negative 5.2 squared plus negative 4.2 squared plus negative 0.2 squared. The negatives really don't matter, right? Because you're going to square it anyway. And then 19.8 squared all over 5. Okay. So we can do that. That's not too bad. It's kind of messy. I'm sorry, I'm looking for some notes on that. I don't see it. Okay, so let's take a look at each one of those. You can do the rest by hand. And I guess I can do it by hand. Okay, we'll do it by hand. So 10.2. Oops, I don't have the right calculator. I'll have to use one of these. Gotta find. So using a scientific calculator is really what you want to do right now. Okay, so I'll do 10.2, and then I'll square it. And then you don't need to put in the negatives because you're squaring. 5.2 squared, 4.2 squared, 0.2 squared, 19.8 squared, and then you got to add that up. Okay, so add that up. I get 540.8. So 540.8. And you can divide by 5, and then you can do the square root of that. So you divide by 5, I get 108. And see how that's too big? That's like, that doesn't show you a spread of those types of scores. So I get square root of 108.16. And then let's square root that. And I get 10.4. So 10.4 is the data you're looking for. That's the value. That gives you a better representation of the spread of this data. And it's like these are pretty close together, but these are not. 65 and 70 is 5 apart. 65 and 75 is 10 apart. But then these are close, but then the 95 and 65 are really far apart. So it's talking about the calculation shows you how far is all the data points from the mean. And if you go 10.4 and 10.4 on either side, then from the mean, you're going to get basically all but one data point. The only one left is that 95. Then you got to go 2 standard deviations away to, or 3, 10, 20, 70, 80, 90. Yeah, 2 and a little bit. Then you get the 75. So that's what you're looking at. And then there are some interesting results of that with the standard deviation. Okay, let's see where we're at. I think we hit everything. So variance is before you square it, we did the range, we did the mode, and all of that. So look at some examples now and the homework. You'll be doing a couple calculations, and that's pretty much wraps up section 4. Yeah, I think so.